This is like the third time I've tried recording this, so I'm sorry if I just sound defeated and annoyed because I am, because I want to go home. um, Here's important information. Pause it, read it. I'm moving on. Okay. We're on page number 12 in our notes. We are crossing out the section that says Earth's atmosphere's gases because we're going to come back to this or talk about it more when we go over climate change and the greenhouse effect. So don't worry about it for now. We're just going over the Earth's atmosphere's layers. So I'm going to move my face over. So if you're watching this after the ozone depletion lab, which most of you will be, we were doing a little demo on how ozone forms and is depleted in our ozone layer. Now, the ozone layer is in the stratosphere, but the atmosphere is broken up into several different layers because they do have these distinct qualities about them. The atmosphere is about 3,000 kilometers high. It's about I don't remember how high it is in miles. I'm not gonna try and guess, but it is about 3,000 kilometers high. After that, we get into space. And what kind of defines where our atmosphere is? It's what gases are present and they're being held near Earth due to Earth's gravity. So the exosphere is the layer that is furthest away. This is where satellites are orbiting around our planet. The thermosphere is the layer below it. This one has very drastic changes in temperature, which we'll talk more about later. The mesosphere is the middle layer, M for middle, M for meso. This is where if asteroids are coming towards Earth and they are small enough, they will burn up here because they're very hot and they have a lot of kinetic energy, and they do burn up in this layer. The stratosphere is where the ozone layer is. This is a very important layer because if you remember from the lab, the ozone layer protects us from the harmful UVC rays that cause skin cancer and cataracts. And the troposphere is the sphere that we are currently in. This is where we have our weather. This is where planes are flying. It's our layer of the atmosphere that we associate with the most. Okay, please work. Okay. Whew. Okay, let me move my face. I'm going to crash out if this pauses again. I'm going to freak out. Okay, so in the stratosphere, ozone is very beneficial to the survival of all life on Earth. Before the ozone layer, no life could exist on land because the land was so hot and the UV rays that were coming down from the sun were incredibly harmful. So after photosynthetic organisms breathed out enough oxygen, they started doubling up and tripling up to form what we now know as the ozone layer. And this ozone layer protects us from the harmful UVC rays.
This announcement is for all seniors football players. All seniors football players, please report to room B like boy 123. That's B boy 123.
So this layer protects the Earth from the harmful UVC rays, and we're going to go over that today. We did kind of briefly go over it in the lab, but I want to make sure that we go over it now. Light turned off. Turn back on. Hold on. So, what the heck? Here we go. Okay. Now, in your notes, you should be on page 13. You don't have to draw this exactly as I have it because it's going to change a lot, but you do want to draw something very similar. So, here is the Earth. This would technically be the ozone layer, and here is the sun. Here we have dioxygen. This is just two oxygens together. It's O2. UVC breaks down O2 into two free oxygen atoms, but these oxygens don't like being single. They want to be with somebody else. They want to be with another oxygen. So they will bind with other free oxygens in the atmosphere. Remember, this oxygen is getting into our atmosphere because of photosynthetic life on Earth, like trees and algae and plants. So 1 plus 2 is 3, and O3 is called ozone. And this reaction is reversible, where UVC will also hit O3 and the reverse happens. So when you break down O3, you break it down into O2. This can then be hit and be broken down into O1, but the cycle just continues and continues and continues. Essentially, what you need to know is UVC hits oxygen molecules in the stratosphere, breaking them down. Oxygen does not like being single. It also does not like being in a couple. They like to be in a throuple. That's just how they roll. So they will reform and break down, preventing UVC from hitting the Earth, which is great because UVC is very harmful. So this is a continued formation and breakdown of ozone. Now, unfortunately, because humans are just so great and we love messing everything up, we unfortunately are contributing to ozone depletion. So, in your lab, once we did the first 2 years, you guys then did it again, but you now had more ozone breakers than you did ozone makers. So, we were simulating the introduction of something called a CFC. And a CFC is something called a chlorofluorocarbon. So CFCs are a primary anthropogenic, which means human. Anything having to do with humans is anthropogenic, a human, non-natural way. So CFCs are a primary anthropogenic cause of O3 breakdown. They act just like the UVC. So CFCs come from things like refrigerants, chemicals, hairspray, anything that has aerosol in it, and they do the same thing that UVC does is they break down ozones. They're also home wreckers. So what happens is this UV radiation.
You staying?
No, I'm recording a video.
You're staying?
Yeah.
Bye.
Bye. What happens is UVC is going to hit CFCs in the atmosphere, and this causes a chlorine to break off. Now, this chlorine is also a home wrecker, and it doesn't like being alone. So it's going to steal one of the oxygens. So this chlorine, again, does not like being alone. It's going to steal one of the oxygens. It does not like the throuple. It's going to steal it, and it's going to be bonded to that new oxygen. Now we have an issue where not only is UVC breaking down the ozone, but so is this chlorine. And oxygen doesn't like being with the chlorine. It wants to be with other oxygens. But unfortunately, chlorine keeps reacting and reacting and reacting and stealing all the oxygens. And the problem with this is one single chlorine atom can stay in the atmosphere for 50 to 100 years and can destroy up to 100,000 ozone molecules. So it is a devastating impact to our ozone layer because naturally UVC will break it down and we have no issues because it's so busy only breaking down ozone. But now that our CFCs are now breaking down ozone, it's giving the chance for our UVC to slip past the ozone layer and hitting Earth's surface directly. So the problem with this is, like we were discussing last class, is UVC has direct impacts to rates of skin cancer and cataracts. So in the 1980s, we noticed that the amount of ozone over Antarctica was decreasing each year. And then this was actually happening all around the world, but most significantly at the North and South Pole. We then linked it to CVC production. And again, CVCs are, I keep saying CVCs. I'm so sorry. CFCs. Again, I've recorded this 3 times and I'm annoyed. CFCs are released during any hairspray, any chemical refrigerant, and this was directly linked to ozone depletion. So because of that, and because this was such an issue, now that humans and animals were having higher cases of skin cancer and cataracts, we came together as a global society and we came up with something called the Montreal Protocol. So 24 nations signed this protocol, which committed to reducing CFC production by 50% by the year 2000, and they did. And eventually, more than 180 countries eventually signed off. And even though the chlorine that's in the atmosphere is still here today, it meant that no new CFCs were going to be released into the atmosphere. So we still need things like hairspray. We still need things like refrigerants. So they had to come up with alternatives. These are called hydrofluorocarbons, and it doesn't relate to ozone depletion, but it is a greenhouse gas. So, yay, we're saving the ozone layer. Boo, we now are contributing to climate change. So, it's kind of like a win-lose situation, but so is a lot of things in this course. So, when you guys are done, is this still in your notes? It is. Work on those 2 questions and then you're done with notes. I'm sorry, that was a bit longer than I wanted it to be. My bad. Interrupted by a few things. I hope you guys have a good day. I will be here after school, like literally every day, and I'm also here every day during advisory if you want to go over soil series lab, ozone depletion lab. I'm here. If you need help with anything, just come. We can work on it together. I'll see you guys in class. Bye.